Hook. There are $60 billion worth of treasures sitting on the ocean floor right now, 3 million shipwrecks scattered across every ocean on Earth. But here's the thing most people don't realize. Finding gold underwater is nothing like finding it on land. You can't dig, you can't see more than a few feet, and the pressure would crush you like a tin can. So how do we do it? We send robots. The problem: 95% of the ocean floor has never been explored. Think about that. We have better maps of Mars than we do of our own seabed. And somewhere down there, buried under centuries of sand and coral, are ships carrying gold, silver, and emeralds worth more than the GDP of some countries. The San Jose galleon alone, sunk off Colombia in 1708, carries an estimated $17 billion in treasure. The 1715 treasure fleet dropped $2 billion across the Florida coast, and Mel Fisher spent 16 years of his life searching for the Atocha before finding $450 million in gold and silver. But the ocean doesn't give up its secrets easily. At depth, there's no light, no GPS. Water absorbs radio signals. The pressure at 4,000 meters would crush a submarine. And gold is invisible to most detection equipment. So treasure hunters had to get creative. They had to build machines that could see in the dark, feel through sand, and pick up a single coin from the bottom of the abyss. Phase 1, the search. The first step in any deep-sea treasure hunt isn't diving, it's listening. Side-scan sonar works by dragging a torpedo-shaped sensor behind a ship. It fires sound pulses at the sea floor and measures what bounces back. Objects cast acoustic shadows, just like objects cast shadows in light. A shipwreck shows up as a distinctive bright spot with a dark shadow behind it. Modern systems can detect objects as small as half a meter from hundreds of meters away. But here's the limitation: sonar only sees the surface. If a wreck is buried under sand, sonar is blind. That's where magnetometers come in. These sensors detect distortions in Earth's magnetic field caused by metal objects. Iron cannons, steel anchors, chains. Even when buried 3 meters under the seabed, a magnetometer will find them. But here's the plot twist that surprises everyone. Gold is completely invisible to magnetometers. It's non-ferrous. A magnetometer can't tell the difference between an empty patch of ocean floor and a chest full of gold coins. So what do treasure hunters actually look for? Iron. They find the cannons first, because where there are cannons, there was a ship, and where there was a ship, there might be gold. That's exactly how Mel Fisher found the Atocha. His custom-built proton magnetometer detected iron cannons buried in sand off the Florida Keys. The gold was sitting just meters away. Phase 2, the scouts. Once sonar and magnetometers identify a possible site, the next step is sending in the scouts. These are autonomous underwater vehicles, AUVs. Unlike the robots you see in movies, AUVs don't have operators. They're pre-programmed with a mission, released into the water and left alone for hours or even days. Chol. The REMUS 6000 is the robot that changed everything. Built by Woods Hole Oceanographic Institution, it can dive to 6,000 meters and carry side-scan sonar, cameras, and magnetometers simultaneously. In 2015, a REMUS 6000 descended to 600 meters off the coast of Colombia and photographed something that treasure hunters had been searching for since 1708, the bronze cannons of the San Jose galleon engraved with dolphins. The identifying mark that confirmed a $17 billion discovery. Ocean Infinity took this concept further. Instead of one AUV, they deploy entire fleets. 6 Kongsberg-Hugin AUVs operating simultaneously, each costing $5 to $8 million. In the search for Malaysian Airlines flight MH370, their fleet covered 125,000 square kilometers in just 138 days, more area than a previous 2-year search using traditional methods. Phase 3, the recovery AUVs find the target, but they can't pick anything up. For that, you need the heavy machinery, remotely operated vehicles. ROVs are connected to the surface ship by an umbilical cable that delivers power and transmits live video. A human pilot sits on the ship, watching through the robot's cameras, controlling every movement in real time. The key technology is the manipulator arm. Modern work-class ROVs carry two arms with 7 degrees of freedom, the same range of motion as a human arm. They can lift 100 kilograms at depth, apply precise torque, and handle objects as delicate as porcelain dishes. The deepest commercial treasure recovery in history happened in 2013 when Odyssey Marine Exploration sent ROVs down 4,700 meters, deeper than the Titanic, to reach the SS Gairsoppa, a British cargo ship torpedoed by a German U-boat in 1941. Over multiple missions, their ROVs recovered 110 tons of silver, 2,777 individual bars, each one plucked from the ocean floor by robotic arms in total darkness. The largest precious metal recovery from the deep ocean ever accomplished. But it's not just about treasure. When Robert Ballard found the Titanic in 1985, his towed camera sled, Argo spotted one of the ship's boilers at 1 in the morning. The next year, he returned with the manned submersible Alvin and a small ROV called Jason Jr., compact enough to enter the Titanic's interior through windows and doorways, filming the grand staircase for the first time in 73 years. The economics. Here's the question nobody wants to answer. Is any of this actually profitable? A work-class ROV costs $1.5 to $3 million to buy. Operating one with a vessel and crew runs $30,000 to $75,000 per day. A typical deep-sea expedition costs $5 to $10 million before you recover a single coin. And then there's the legal nightmare. Odyssey Marine spent years recovering $500 million in silver coins from the Mercedes. A Spanish court ordered every single coin returned. The San Jose's $17 billion in treasure has been sitting untouched since 2015 because Colombia, Spain, and indigenous groups can't agree on who owns it. But the technology keeps getting cheaper. AI systems can now auto-detect shipwrecks and sonar data. Soft-bodied robots inspired by deep-sea creatures don't need pressure-resistant hulls. The deep-sea robot market is projected to nearly double, from $2.8 billion to $5.1 billion by 2030. Entry-level exploration ROVs now cost under $10,000. The next generation of treasure hunters might not be corporations with $100 million budgets. They might be individuals with a laptop, an AI, and a robot small enough to fit in a backpack. CTA 3 million wrecks, $60 billion, and robots that are getting smarter, cheaper, and deeper every year. The golden age of deep-sea treasure hunting isn't history, it's just getting started. If you want to see which specific treasures are still out there waiting to be found, check out our episode on the San Jose Galleon, the most valuable undiscovered shipwreck on Earth. Link is in the description. Hit subscribe so you don't miss the next dive. And drop a comment. If you had an unlimited budget and a fleet of robots, which shipwreck would you search for first?